Hello everybody, this is day 12 of Advent of Code puzzle challenge, and today's puzzle is about Cardan groups. So we and our historians, we came up to some kind of garden, and over there is some massive farm. And we want to work over there, but elves have asked us that different plant groups need to have different fences around each other, so that we have this kind of region, like a map that contains different plants, and for each of those plants we need to find out what is the perimeter and the area of that particular plant. So yes, so if we have this kind of setup, then we can see that this A, the plant A, it has a perimeter of 1, 2, 3, 4, 5, 6. It has a perimeter of 10. This D has a perimeter of 4. This B has a perimeter of 8. E has a perimeter of 8, and the C, I think it was a 10, just like the A had. So yes, so we need to calculate the area and the perimeter for each of the different plants, and then just sum out the perimeters times the area. Yes, that is what we need to do. Our configuration can be like as this as well, that one plant group covers the other plant group like that. And yeah, so, and here is some larger example, and so we need to find out all the regions, how they are going. So all right, let's try to do it. So how will I do is that I will do the flooding, so that I will just check one of the element, and then I will check if it's in the if it's a border element, if it's near the end of the grid, then I will just count that this is one side of the perimeter, and I will just count all the time that the neighboring, if like for example, if this A element, I will check for upper, right, down, and left, and if the upper one is not the same element, then the perimeter counted. Then if I check from this A, I check to the right, and if it has the same element, then the perimeter did not increase. Then I check from to down, it does not have the same plant, so perimeter increases, and the same thing goes for the left. Yes, so this is our idea, and for area we just count how many elements there are in one of this in one of this plant region. All right, let's start to do it. I have set it up my Python over here, so my input is over here, and yeah, so let's try to do it. So it is for x in open input.txt, and I will put some element create over here as well. So I will do it so that k equals list of x dot strip. Let's remove the new line, and then also yes, I think this works, and then I just do create dot append k. Yes, this is how I get all the data. So for x in grid, I will just do print x. So this should give me the list of all the elements stored in a data array. And yeah, yes, very good. And before we start to do something, we should also do some kind of like visited places grid. Well, I would call it data grid, maybe the data grid or something like that. Well, it's not that good name for that, but I will do it like that, x length equals length of grid 0 and y length equals the length of the grid, like that. And so we just initialize some variable that is the size of the regular grid, but each value over there has some peak number. It's like not visited places. So we can initialize it like this. We have this curly braces, and then we have let's initialize them with like some peak number, like for example 1000 for I in range x length, and then let's do for j in range y length. All right, and let's just for debugging purposes, let's set the data grid 0 of the elements. Let's set it as a 0. And yes, so let's see, for x in data grid print x. So yeah, so probably we will have something that all the elements are 1000 and this 0 of the element is 0. So in range, yes, in range like that. So yeah. Yes, very good. The data grid is initialized as well as that we have all the elements in our garden plotted in a grid. All right. So what we can do is that we can do somehow that, let's say, cur element equals grid 0 0. Let's start from the upper side, and then we have to make some method. Let's call that total equals 0, and then total plus equals, I don't know, some method, find area times perimeter, find area times perimeter, for example, like that. And so to this method we have to call in current, well, let's call it maybe, okay, let it be current element, so that over here let's call in current element and just y and x coordinates. We have to do it later as an for loop, but let's first finish up this method, and then we can do everything for loop, and then we can finish it off. But yeah, so this find a times b is the method where the most of the magic is happening. All right, let's get it. Def find a times b. So it has three inputs. The current element, we can also call it, like, for example, plant. So it's just like the name that's getting inside, and then y and x coordinates. And so in this method, I know that the first thing what we have to do is some kind of variable declaration. We can say that, for example, area is it's definitely 1 at the first. So we already have one element. So the other one is perimeter. So what the perimeter could be? For each element that we have over here in the list, we have to check. We will check all the neighboring elements. So if the neighboring elements is a border, or if some other elements not at the same plant, then we will increase it. So at the start, let's initialize it as a perimeter that it will be 0. And then if we do this kind of flooding, flooding method, or if you're checking the next elements, then we have to have some kind of index as well. Let's call it like continuous index or something like CI. So this is the thing that will be written to this data grid. And yes, and just that we don't want to loop through all of them. We don't want to loop in each iteration. We don't want to loop through all of the grid elements. We just want to loop them through in the same places that some changes occurred. So let's store the new elements to some variable as well. Let's call it maybe current stack, and just add it up. Let's add up the initial element to this as well, and then in the end we also have to do that all of the things that we change in this data grid, we have to put them some new value. So let's call in one more variable, and let's call it all stack, and let's also initialize it with the same initial value. All right, so now we have almost something ready. So let's do while true. Here we can have some kind of copy stack. Let it be copy deep copy. So let's import copy. Let's copy stack. Let's copy current stack, and current stack, let it be current stack, let it be 0. All right, and now let's do, and yeah, we have to yes, and we have to have also the data grid y x. Let's initialize this with this continuous index as well. And now let's see that the continuous index, let's increase it by 1. All right, now what we can do, so it is a for element in copy stack, for element in copy stack, let's see. Yes, so now we have to check all the neighboring places. We have to check all the neighboring places. So the copy stack, this will also have a list of the coordinates that have a list of coordinates, and we have to check the neighboring elements for that. So let's first get some, I don't know, y start, x start, let it be element 0 and element 1. And now let's see somehow, let's do so that perimeter will increase if there's some other thing in the neighboring place. So perimeter increase, and so let's do it. Find neighbors. Yes, like that, and we have to check it for 4 different directions. So let's do it 4 times. And yeah, and this find neighbor, since it's probably going to use some this current stack and all stack elements and also this area. So let's initialize this find neighbors method inside our current method. So let's say def find neighbors. And so what elements it will have? It will have, I don't know, y s and y x. I hope it's enough. I hope it's enough for them. And here we just have to put in 4 different neighboring elements. So let's start it from up right down and left. So the upper element has okay, I will do it so that the initial variables, let them be some let them be y start, and let this one as also be x start, and let these things just be y and x. So it's a little bit easier like that. Yes, and also here let them be y and x. So find neighbors. So the upper one has a y coordinate that's one less, and the x in upper is gonna stay the same. On the right side, y is the same, x is increased by 1. On the bottom one, y is increased, the x is same, and on the left hand side, y is the same and the x has decreased. All right, I hope they are like this. I hope so. Yeah, these are the checkings that will check all the four adjacent places. Okay, now let's see some kind of find neighbor. And maybe I also would like to give out the plant name. Let's call some plant as well over here. Maybe it's needed. Find neighbor and plant. So the find neighbor, what it should be. If so, we have two creeds. We have data creed that has just that all the elements are thousands, and we have plant creed. So wait, yes. First thing we have to do is that we have to check if it's a border element. So yeah. So first thing we have to check if otherwise we will get out of bounds exceptions. So if y is like that, and I don't know, length of data grid, and also the same for the x. X is length of data grid 0. If it is in this kind of region, then we do some logic. Else it is a corner place. This is a border place. So else we will return 1 because we want to have this value to return as a perimeter value. So over here, let it be return 1. Okay. So yes. Now the second thing is we need to check if data grid this is a y and x equal 1000. If it is 1000, then we found a new neighboring element. If it is 1000, then we will increase it with a continuous index. So yes, we will increase it with a continuous index. So I think we have to include it somehow over here as well. I know that there are some method like a non-local a and maybe also continuous index, non-local area. It's like that. Yes, so it is. If it is like that, then the same method, this digit grid y and x will have this continuous index value, and also add the same thing to our current stack and to all stack. So yes, so let's see, current stack dot append. So it will be y and x, and also to all stack append y and x. And thus we need to do everything else, and yes, and also we have to increase the area plus equals 1. And if it is like that, then also let's return 0. All right, we will just return 0 because we had a new element neighboring, so this will do not increase the perimeter side. All right, now let's see. We I hope it will work. But before we test it, let's try so that we will end out this loop as well. So our new method adds a stack to the current stack and to the all stack. Yeah, so if everything in copy stack, wait, it is copy that the copy. We have to do it as well like that, otherwise the both of the elements will get changed if we change some value. Yes, and now yes, now we will do it so that the current stack is the current stack has been added in this method. Yes, so all of these find neighbors are adding some stuff to the current stack, and if this loop is over and if current stack is empty, then we are ready to break the loop. Then we are ready to return something. So if length current stack equals 0, then we could just return perimeter times area but it's the tricky thing is that if we are returning, then we already changed this digit grid. We would like this digit grid to stay the same as it was before. So let's do it as well. So for digit grid, let's see. So it's for element in all stack. For element in all stack, let's see. Y1 x1 equals element 0 element 1, and let's see that data grid y1 y2, let's just place them with some random value that does not need so that it will just mean that we have been over there, and it has been initialized. So well, it has been checked, so we don't need to check it again. But yeah, but because if we would leave it as a 0 or something, then there might be some problems. All right, let's see what we have. Print total. Let's see what we're gonna have. Everything works. List index out of yes, so these things have to be less than length of the grid. All right. Return perimeters times area. So this is our perimeter. So what it is? Area is 16 and the perimeter is 49. They are a little bit bigger because it was only for one element, so that the element is A. It's a little bit too big. Let's start to debug it. Let's see find A times B, yes. Area, perimeter, current stack, all stack. Data grid is yes, while true. Continuous index, copy, current stack, copy stack. So copy stack has just one element. All right. Find neighbors. What does it do? Perimeter is 1. Find neighbors. Yes, perimeter is 1, 1, 1. No more elements over here. Length of current stack. So, what is our copy stack, current stack? Current stack. Current stack has 2 elements. Copy stack. Let's see. Copy stack. Copy stack should have only 1 element. Wait, let's do it one more time. Yes. Copy stack. Current stack is like that. Current stack append, all stack append. Current stack append, all stack append. Current stack. Why does it? Wait. Oh yes. We don't have any checking for this plant. Yes, we need one more checking. If data grid y and x equal plant, like we need this kind of checking as well, right? Yes, I think like that. Let's see what we have right now. One checking was missing. Return perimeter. Perimeter is 4 and the area is 1. So yeah, but anyway, well, this is how it works somehow. I could also check it from the part 1. I already did it. Yeah, so well, this is how it works anyway. So yes, so in part 1, well, it did work. I leave the comments below. And yeah, so yeah, in anyway, sort of this, like it works, sort of that. Yeah, and so yeah, I will copy my part from the part 1. It is quite the same, and yeah. This is how it works. I think something was wrong over here. But anyway, yes. So this is how it works. Yeah, and let's see for the part 2. Part 2 was a little bit different. Over here there was some bulk discussion, so that you have to check the side lengths. Side lengths, not the perimeter, so that the A method has 4 sides, and yeah, so you have to check the sides, not the perimeter. And anyway, it was a little bit trickier one. Here from the Reddit solutions, I found this kind of solution from Polarix Spiral, that for the sides you can just check one side. You will check the corners, and you will check it from the edge cases. Are they, if they're both the same, then it's a edge. And yeah. Well, anyway, yes. So yeah, the part 2 was a little bit trickier, but anyway, I think I will end it over here. So yes. So see you next time.